Here is our video for the second partial project. We are going to calculate different values of the f of x, of the function f of x equals x cubed minus 3x squared.
So in our function, we are looking for restriction on the value, and since it's a polynomial function, we don't have any restrictions. And by looking at the graph, we can assume that the domain belongs the x to all the real numbers.
Now to find the x-intercept of this function, we have to substitute the values of x. We substitute them with 0 and it gives us f of 0 equals 0. So the first x-intercept will be in 0, 0. Then we substitute f of 3, that it gives us f of 3 equals 3 to the cube minus 3 times 3 to the square. This will be f of 3 equals to 27 minus 27, so f of 3 will be equal to 0. Now our second x-intercept will be 3, 0. For the y-intercept, we already get it from the previous with the x-intercept, so it will be that substitute 0 into the values of x and we get 0, so the y-intercept will be 0, 0. Now we are going to get the symmetry of this function. We have 2 even and odd. For even we have to get this condition, and for odd this one. So we get the function of f of minus x, and we see that f of minus x, f of x is not equal to f of minus x. Therefore, you don't have an even symmetry in this function. For the odd, we have to achieve this condition. We get the minus f of x, and we compare and we see that it's not equal as f of minus x, so therefore we don't have odd symmetry.
So we have to find the vertical, the horizontal, and gaps in this function. And since we don't have any conditions of this, we have that any of these do not exist in the function. So we apply power rule to our original function and we obtain the first derivative.
Now we're going to present the ID test for the first derivative. First of all, you have to get the zeros of the first derivative. Now, from our first derivative is 2 and 0. Then that we have the zeros, we substitute those values to the original function for the values of x, and we get this one. For 0, we get 0, and for 2, we get minus 4. We have the two other points. We have to analyze what's happened around these 2 points. That's why we have to analyze minus 1, 1, and 3 that are between this interval, these points. Now we substitute in the original formula these values, so we can get the other values that are missing. Now that we have the other points to complete the graph, we analyze the behavior of the graph. We see that in this point, the graph goes up, and then we see that this point, this 0, this critical point, is our maximum point. Then we see that the other one, it's decreasing and then increasing, so this one is our minimum point.
So from our first derivative, we derivated again applying power rule, and we obtain the second derivative.
Now the second derivative test, which is with the inflection point. First of all, you have to get the second derivative that we already have. Then we have to get the zeros of this new derivative. Our zeros are x. Our 0 is 1, 1, 0. So now we have our first 0, our only 0, that is 1, 0. This value we substituted to the original formula, the original function, and it will get us a minus 2. Our inflection point will be 1, minus 2. So now we do our t-chart to analyze what is happening around that point. So we have 0 and 2. We substitute these values into the formula, and we get these other values, 0 and 4. Now we know that the concavity around this point will be concavity from 0 to 1x, concavity down or negative, and from 2 will be concavity up or positive.